Have you ever seen a massive machine repeatedly slamming into the ground without any cables, without electricity, yet somehow it keeps running as if it's alive? How is it possible that a machine can ignite itself just by falling? Why does every impact sound like a small explosion, even though you can't see any fire? And strangely, why does this machine often perform even better when the ground is harder? Before we uncover the secret behind this incredible technology, make sure to subscribe, because after this, you'll never look at heavy machinery the same way again. Imagine standing in the middle of a large construction site. Dust fills the air, engines roar in the background. And then there's one machine that dominates everything around it. A tall vertical structure, repeatedly striking the ground with a deep, rhythmic sound. Duck duck DUK. Each adar feels like it vibrates through your entire body. This is the diesel hammer. At first glance, it looks simple, almost primitive, like a heavy piece of metal being dropped over and over again. But inside, something far more intense and fascinating is happening. Inside the diesel hammer, there is a long cylinder and a heavy piston that moves up and down. At the beginning of its operation, the piston is lifted to the top, usually with the help of an external mechanism. Then, it is released. As it falls due to gravity, it accelerates rapidly downward. Inside the cylinder, air becomes trapped and is compressed to an extreme level. As the piston continues its descent, the pressure rises dramatically, and so does the temperature. In fact, the air becomes so hot that it reaches a point where it can ignite fuel without any spark. Right before the piston reaches the bottom, diesel fuel is injected into this superheated, high-pressure air. In that exact moment, something remarkable happens. The fuel ignites automatically, without a spark plug, without electricity, purely from the heat of compression. This creates a small but powerful explosion. That explosion generates enough force to push the piston back upward while simultaneously driving the pile deeper into the ground. As the piston rises, gravity takes over again, pulling it back down. The cycle repeats: fall, compress, ignite, explode, rise over and over again, as long as fuel is supplied. In essence, the diesel hammer operates on a simple but brilliant principle: gravity, air compression, and auto-ignition. It works similarly to a diesel engine, but instead of rotating like a car engine, it delivers its power through repeated vertical impacts. The loud DUK sound you hear is not just metal hitting metal, it is a combination of mechanical impact and internal combustion happening at the same time, giving it that explosive, powerful signature. To truly understand where this idea came from, we need to go back to the late 19th century. A German engineer named Rudolf Diesel was searching for a more efficient alternative to steam engines. He discovered that fuel could ignite on its own under high pressure, a breakthrough that led to the creation of the diesel engine. This concept later inspired engineers in the early 20th century, when rapid infrastructure development demanded faster and more efficient ways to drive piles into the ground. By adapting the principle of diesel combustion into a vertical impact system, the diesel hammer was born. What makes this machine even more interesting are the details that many people don't realize. It doesn't require electricity at all, making it extremely useful in remote locations. In some cases, harder ground can actually improve its performance because higher resistance leads to better air compression and more efficient combustion. On the other hand, if the ground is too soft, the compression may not be sufficient to ignite the fuel, causing the hammer to stop working. Despite its powerful performance, the mechanism itself is surprisingly simple compared to modern machinery. In a way, its continuous cycle of falling, igniting, and rising resembles a heartbeat: steady, repetitive, and alive. Of course, like any machine, it has its strengths and weaknesses. It is highly durable, independent of electrical power, and extremely effective for heavy-duty work. However, it is also very noisy, produces strong vibrations, and emits exhaust from diesel combustion. Still, its reliability and simplicity keep it relevant even today. What seems like a rough, brute force tool from the outside is actually a carefully balanced system of physics, pressure, and combustion working together in perfect rhythm. It is a machine that quite literally comes to life through its own powerful reminder that even the simplest looking tools can hide extraordinary engineering within them.